For today's deep dive, we are pulling from a really fascinating stack of research. It's anchored by this standout article from Technology Review, and it's titled Kids Outlearn AI, and we still don't know why.
Yeah, it's a great piece.
It really is. So our mission today is to kind of figure out how a human toddler, consistently beats a supercomputer at mastering language.
Right.
And we're also looking at this through a very specific historical lens because our sources note that it has now been exactly 4 years since the groundbreaking release of ChatGPT.
4 years. It's wild to think about.
It's crazy, right? Like, we've had 4 years of this explosive, just exponential growth in generative models, and yet there's a fundamental cognitive gap that the smartest engineers in the world still haven't been able to close.
No, they really haven't. And I mean, it is the defining paradox of modern technology right now.
Yeah.
We are pouring literally trillions of dollars into mimicking human intelligence, and yet the biological blueprint that we are trying to copy remains, well, fundamentally mysterious to us.
Okay, let's unpack this because to really appreciate the scale of this mystery, we have to look at the contrast. Like, on one hand, you have the absolute cutting edge of artificial intelligence. Massive, sprawling data centers.
Right.
Acres of servers just humming away, consuming the electricity of a small city, backed by just, infinite processing power and algorithms that have literally crunched the entire internet.
Yeah, all of it.
All of it. We have supercomputers that can effortlessly pass the bar exam. They write complex software code, process medical diagnostics, all of that.
Yeah.
But then you step outside that multi-billion-dollar server farm and you walk over to a local park and you look at a 4-year-old sitting in a sandbox.
Right.
And that toddler, who is currently, trying to eat a handful of dirt.
Literally eating dirt, yeah.
Exactly. Eating dirt is basically running laps around the AI when it comes to truly mastering the nuanced fluency of human language. So how is this possible?
Well, what's fascinating here is that technologists and cognitive scientists, they aren't just observing this phenomenon as some, quirky piece of trivia.
Right.
They are actively scratching their heads over it. I mean, it is a genuine scientific mystery.
Wow.
Yeah, because you would think that with 4 years of relentless iterative advancements since those early generative models dropped, the sheer brute force of computation would have closed the gap.
You would think so, yeah. Because they just keep getting bigger.
Exactly. The assumption in Silicon Valley was always that more compute and more data would eventually yield perfect human parity.
Right.
But the human child retains this unmatched edge in achieving perfect intuitive language fluency, and the field is genuinely puzzled as to what that secret sauce actually is.
I mean, it forces a complete reevaluation of how we measure intelligence, doesn't it?
It really does.
Because we have been operating under the assumption that if you just feed a machine enough text, like literally every book, every article, transcription, every forum post ever recorded.
The whole data set.
Right, you feed it all that, and it will eventually just know language the way a human does.
Right.
But the source material draws a really sharp distinction here regarding the mechanics of learning. It points out that AI relies on vast data sets and explicit programming. Whereas in contrast, children possess natural curiosity and adaptability. The text emphasizes the kids learn intuitively, effortlessly picking up on social cues, context, and all those unwritten nuances of communication.
Right, and that distinction, the one between explicit programming and intuitive learning, that is the entire crux of the mystery.
Yeah.
Because an AI model learns by processing static text in a highly structured way. It basically calculates the statistical probability of the next word based on billions of previous examples.
Just math.
Right. It is, at its core, a staggering mathematical exercise.
Yeah.
A child, on the other hand, does not learn language by calculating probability.
No.
A child learns language as a biological tool, to navigate their immediate reality and get their needs met. They are engaged in a dynamic living environment, not just some static data set.
I want to push back on that framing, though.
Okay, sure.
Because if we are saying AI relies on vast data sets, isn't a child's life just a different kind of data set?
Well,
Like, the article separates explicit programming from a child picking up social cues, but from a strictly mechanical perspective, isn't picking up, say, a mother's smile or a father's change in tone, isn't that just another data input?
Hmm.
Like if I'm a machine learning engineer, I might argue that the child just has a more multimodal data set, right?
Right.
Audio, visual, tactile.
Right.
So why is it categorized as something fundamentally different from what the AI is processing?
See, I have to challenge the idea that a lived experience is just a multimodal data set because that kind of strips away the entire biological mechanism of how learning actually happens.
Okay.
And honestly, the debate you are raising is exactly what is tearing the field apart right now.
Oh, really?
Oh, absolutely. But the source highlights a critical difference, and that is the architecture of the learner and the nature of the data itself.
Okay, break that down for me.
So an AI requires its data to be explicitly structured. It has to be cleaned, scraped, and fed into an architecture that is programmed to look for specific statistical patterns.
Right, so it's very neat.
Yes, very neat. The learning is entirely directed and bound by the parameters of the code. But a child environment, by contrast, is incredibly messy. It's chaotic. It's sparse.
Right, it's just real life.
Exactly.
Yeah.
A toddler doesn't read a million perfectly structured sentences to learn grammar. They hear a few fragmented sentences muttered by their parents. They see a dog run by, they feel the wind on their face.
Yeah.
And somehow their brain intrinsically maps those chaotic sensory inputs to abstract linguistic rules.
Wow. Okay. So is the difference between being spoon-fed a highly organized encyclopedia versus, like, being dropped into the middle of a chaotic city and being told to figure out how traffic works?
That is a great way to put it. That captures the environmental difference perfectly. But there is also the internal mechanism to consider.
What do you mean?
Well, the child has natural curiosity, which the source explicitly calls out. They actively seek out information to reduce uncertainty in their world.
Oh.
Like if a toddler drops a cup of milk and it spills, they immediately look at their parent to gauge the reaction.
Oh, yeah. Every parent knows that look.
Exactly. They are conducting a physical experiment with reality and monitoring the social fallout.
That's hilarious, but yeah, it's true.
And that adaptability, that intuitive grasp of social context, like understanding that a sharp intake of breath from a parent means stop before they even know the word no.
Oh, right.
That is entirely absent from explicit programming. Learning a language isn't just about processing text on a screen. It is fundamentally about physical embodiment and an innate biological drive to connect with others for survival and socialization.
Man, that makes the AI look like it is essentially trying to learn how to swim by reading a dense textbook about fluid dynamics.
Yes.
While the kid is just jumping into the deep end of the pool and figuring out how to keep their head above water.
That's exactly it. The AI knows everything about the water, right? It knows its chemical composition, its weight, its temperature parameters, but it has never actually felt wet.
Wow.
The child feels the shock of the cold water first. They feel the panic of sinking, the relief of floating, and then they learn the vocabulary for those experiences second.
That is such a profound distinction.
It is. The language maps to a physical and emotional reality. For the AI, the language maps only to other language.
Here's where it gets really interesting, because the source specifically uses the phrase current AI models.
Right?
It notes that scientists are questioning whether current AI models can ever truly replicate the human experience of learning a language. And wait a minute, does that imply we are hitting a brick wall with how we build these systems?
It very well might.
Like, if current models can't replicate the human experience, are scientists suggesting we are approaching artificial intelligence entirely the wrong way? Have we just spent trillions of dollars building the world's fastest autocomplete when we should have been building something else entirely?
Well, this raises an important question, and it really represents the existential tech hurdle for the entire industry right now.
Yeah.
Because for the last 4 years, as our sources point out, the prevailing philosophy in Silicon Valley has been, well, scale's all you need.
Right. Just make it bigger.
Exactly. The belief was that if we just make the neural networks bigger, give them trillions more parameters, feed them even more data, then human-like understanding will just magically emerge from the math.
But it hasn't.
No, it hasn't. And the scientific doubt highlighted in this article suggests that might be a fundamental misunderstanding of what language actually is.
How so?
Well, if language is inextricably tied to the human experience, like we were just talking about, then simply scaling up a text prediction engine 1,000 times bigger isn't going to cross the threshold into true comprehension.
Because you can't scale your way out of a flawed premise.
Exactly.
Like if I have a calculator that doesn't understand calculus,
Yeah.
building a calculator the size of a skyscraper still won't help it understand calculus.
Yeah.
It will just do basic arithmetic faster.
And that is the exact fear keeping engineers up at night right now. The gap between the toddler and the machine, it isn't about processing power or server size anymore.
Yeah.
It is about the fact that language evolved specifically to express human physical and emotional realities.
Uh,
You know, hunger, fear, love, the need for warmth, the desire for play.
All the human stuff.
Right. And current AI architectures, they don't have bodies, they don't have a society to belong to, and critically, they don't have stakes.
Stakes.
Yeah.
Right, because a toddler needs to communicate to survive.
Yes, to get food, to be comforted. The AI has absolutely no biological imperative. So when scientists question if current models can ever replicate this, they are pointing toward a massive paradigm shift. It forces us to realize that trying to build an artificial brain by just stacking data is exposing how unbelievably miraculous a 4-year-old intuition actually is.
It feels a bit like we tried to build a mechanical bird by just attaching larger and larger jet engines to a titanium tube.
Mm-hmm.
And then we finally stopped, looked at a real pigeon in the park, and realized that the feathers are interacting with the wind in a way that raw thrust just can't replicate.
That's a perfect analogy.
Like, the engineering was impressive, sure, but it missed the biological elegance entirely.
And that realization is deeply humbling for the scientific community.
I can imagine.
It completely shifts the entire set of goalposts. We are being forced to acknowledge that human intelligence is not just a really fast computer locked inside a skull. Intelligence is an embodied, lived experience.
So what does this all mean? Like, we have this massive philosophical revelation.
Mm-hmm.
We are staring down this existential technological hurdle. But let's bring this down to earth for the listener.
Sure.
Because understanding this difference isn't just an exercise in tech philosophy, right? It has immediate, real-world applications.
Absolutely.
The source says this mystery raises critical questions about the future of AI in education. And it specifically points toward the creation of a hybrid learning environment to shape more effective educational tools.
Right.
So for anyone listening who is maybe trying to learn a new language themselves, or parents thinking about their kids' schools, what does a hybrid learning environment actually look like when we know that the machine and the human learn so differently?
That's the key question.
Like, are we talking about an AI tutor
Yeah.
that handles all the rote memorization, while the human teacher steps in to provide the social cues and the intuition?
Well, if we live near the bigger picture, that is the exact vision the source is pointing toward. Once we admit that artificial intelligence and human biology learn in fundamentally different, incompatible ways, we can finally stop trying to use AI to entirely replace the human element in education.
Which has been the fear for a while now.
Exactly. The goal shifts to complementing the human. We take the distinct strengths of both systems and we integrate them.
Because we can't ignore that the AI does have massive strengths, right? I mean,
Yeah.
It doesn't get tired, it doesn't get frustrated, and it literally holds the entire corpus of human knowledge in its memory.
Exactly. The machine brings the vast data sets to the table. Like, think about what an AI tutor can do for a student who is learning a new language.
Okay.
It can provide infinite patience, it can drill a student on complex verb conjugations, and it can instantly analyze exactly which grammatical structures that specific student is struggling with.
Right, because it's looking at the patterns in their errors.
Exactly. And then it can generate thousands of customized practice sentences on the fly just to patch those weak spots.
That's incredible.
It really is. It is unparalleled at personalized data delivery. It can optimize the mechanical transfer of information better than any human ever could.
But, and here's the catch, it completely lacks the intuition to know why the student is failing those verb conjugations on a Tuesday afternoon.
Yes.
Like, the AI tutor doesn't know that the student didn't sleep well the night before,
Right.
or that they're feeling deeply insecure about their accent in front of their peers, or that they actually learn better when a difficult concept is tied to a joke.
Exactly. The AI sees a statistical failure rate in the data. The human teacher sees a frustrated child.
Yeah.
And that is where the human brings the creativity and intuition that the source really emphasizes. A human teacher reads the physical room.
Mhm.
They pick up on all those micro expressions, right? The frustrated sigh, the distracted gaze out the window, the posture of a student who is just giving up.
Yeah, the stuff you can't code.
Right. The human provides the emotional scaffolding, the encouragement, and the vital context that makes the raw information meaningful.
It sounds like it completely reframes the panic around educational technology.
It really does.
Because for the last 4 years, the narrative has been this looming fear that robots are going to replace teachers,
Oh, yeah.
that schools will just be rows of kids staring blankly at screens.
Right. Some sort of dystopia.
Yeah. But if we follow the logic of this research, we should be building tools that actually allow the teacher to be more human.
Exactly.
The AI takes over the brutal, time-consuming heavy lifting of grading and customized lesson planning, and that frees up the human teacher to focus entirely on the emotional and social experience of learning.
It is a partnership, not a substitution, and frankly, this is what children naturally respond to anyway.
Right.
The text makes it explicit. Kids learn intuitively through social cues. So if we want to build effective educational tools, those tools have to facilitate social connection. An iPad that isolates a student behind a screen of infinite data is basically working against the child's natural biological learning mechanism. The hybrid environment uses the machine to deliver the data, but it uses the human to deliver the understanding.
There is a deep, almost poetic irony in all of this.
How so?
Well, the multi-billion-dollar push to create artificial human intelligence has ultimately just circled back to proving the absolute necessity of human empathy.
Wow.
Like, we had to build the most complex, power-hungry machines in the history of human civilization just to mathematically prove that you cannot automate a good teacher.
That is remarkably well put, and the journey to understanding human language learning is far from over.
Right.
As the source notes, this continued exploration is performing two vital functions simultaneously. First, it is actively pushing the boundaries of what AI architectures might look like in the future.
Which we definitely need.
Right. But perhaps more importantly, it is deepening our appreciation for the human mind. The machine holds up a mirror to us, and we are finally realizing how intricate our own reflection really is.
The core tension here is just endlessly fascinating to me. You have the raw power of programmed machine learning on one side, and then the messy innate biological ability on the other. And despite all the hype, despite the staggering pace of algorithmic innovation over the last 4 years, the organic, chaotic, sandbox-playing human brain is still holding the undisputed crown for language fluency.
It really is.
It really does make you look at a toddler babbling in the grocery store with a completely new level of respect.
Oh, definitely.
Like, that kid is running cognitive mapping algorithms that the smartest engineers on Earth cannot figure out how to reverse engineer.
It forces us to add what it truly means to understand something, rather than simply predicting what symbol comes next in a sequence.
Yeah.
And honestly, the sources leave us with a rather profound implication about the future of this technology.
Let's hear it.
Well, if perfect fluency genuinely requires the human experience, the ability to pick up on social cues, to feel physical context, to have biological stakes,
Right.
then maybe language isn't just a complex code waiting to be cracked by a massive data set.
What is it then?
Maybe language is an experience that has to be lived. And if that is true, it leaves us with a pretty wild thought to consider.
Which is?
To ever get an artificial intelligence to speak exactly like a human, we might have to figure out how to give a machine a childhood.